I'm Beth Pariseau, Senior News Writer at Informa TechTarget, and this is IT Ops Query Season 3, Observability in the Age of AI. Charity Majors pioneered the term observability as co-founder and CTO of Honeycomb.io, based on her experience building and managing distributed systems at Parse, Facebook, and Linden Labs, building Second Life. She is the co-author of the O'Reilly books Observability Engineering and Database Reliability Engineering. Her Honeycomb bio adds that she, quote, loves free speech, free software, and single malt scotch, end quote. Hi, Charity. Thanks for being with me today.
Hi, thanks for having me. It's always fun to get to chat with you.
Likewise. I know you've been doing a lot of writing about this lately on your blog, but wanted to ask you, how has generative AI changed observability in your view?
It hasn't really changed anything so much as, software is still software, right?
Mm-hmm.
But I think a lot of the things that we've been saying about the direction that observability needs to go in order to understand these massively complex systems, it's more true than ever. It used to be like, well, it's really better if you have a single source of truth that you're deriving other views from. It's really better if you can trace it. Really, and now it's like, no, actually, if you're using generative AI, it's a trace-shaped problem,
Mm.
right? From when someone asks the question, it's executing the software, it's calling out to different data sources, it's calling out to the model, it gets the model's response, all the way through to the human giving feedback on how it went. That's a trace-shaped request, right?
Mm-hmm.
And high cardinality is more important than ever. Rich context is more important than ever. There are all these startups out there that are raising a lot of money for quote unquote AI observability, which is observability for the model itself, but you can't understand the model in a vacuum. You can only have good observability if it's embedded in good software observability. It's complexity that is driving a lot of this. And really, the surge of generative AI is just like, we thought complexity was increasing fast to begin with. It's now been cranked up even faster. The second thing that I'll point out is that this kind of goes back to even like the sort of classist distinction between software engineers who write the code and that's seen as like super hard and elite and all this stuff, and then ops people who get paid less, get woken up in the middle of the night,
Hmm.
operate the code. There's this perception that writing code is the hard part, which has never been true. It's always been managing the life cycle of software, whether that's refactoring, maintaining, making short-term versus long-term trade-offs, extending, retrofitting. The rise of generative AI and the ease at which it cranks out code at like this incredible speed. This is really like the origin story of Honeycomb, because Christine and I met at Parse, Mobile Backend as a Service. And we had developers all over the world just writing snippets of JavaScript and uploading them. We just had to
Mm-hmm.
make it work. To this day, when people are debugging their code in production, their instinct is to jump straight to, okay, who wrote this? Who knows it? Who is an expert in it? And increasingly, you just can't assume that anyone understands it or is an expert in it,
Sure.
right? And so writing, instrumenting code in a way that it explains itself to you and it helps you understand what's happening in production, its impact on everything else in production, its blast radius. There are tips and tricks that platform engineers have been leaning on all along, but these really have to become more widespread.
Mm. Yeah, I read a blog post you wrote in 2023 about observability driven development and its role in generative AI applications. Can you say more about that?
Yeah, there are so many comforting myths in software development. And I think that so many software engineers grow up with this comforting myth that their IDE is their source of truth. If their test pass, they know it's good. Again, this has never been true, but it's becoming even more not true. The source of truth is always production. You don't know if the code that you have written works or not until you've observed users using it in production. There are just things that you can't
Right,
plan for,
right.
which is why there's almost like this slider of trade-offs of how much effort does it make sense to try and sink in up front to understanding whether or not your code works under these circumstances. And I am in no way arguing that testing is not useful, or it is, all these things are good. But so many engineering orgs put so much of their energy into that front loading and so little of their time and energy into giving themselves a toolkit in production. And the reality is, it's only in the last 5, 7 years that the production toolkit has been widely available commercially in a way that you can compose and buy bits off the shelf. If you weren't at Google or Facebook or whatever 10 years ago, your options were pretty limited. But now the combination of feature flags and Observability 2.0 and all these things, there are only two kinds of engineers. There are some that admit that they test in production and there are some that don't. But everybody tests in production. You have to. And if you don't admit you do it, you're just not investing into doing it well.
Are there any other ways that observability has played a role in development of generative AI apps?
The one thing that is genuinely new that we are in the very early days of grappling with is that it's non-deterministic. APIs are supposed to be deterministic little things. You send it the same parameters, you're supposed to get the same results back. And that's just not true.
Right.
And anybody who says that they know how we're going to solve this is they're lying, or they're trying to raise money, which is super common right now. Nobody knows really how we're going to resolve this, but the problem set of how do we merge software engineering best practices, which are all about determinism, with this element of non-determinism is, I think, really meaty. And to your specific question about how observability interacts with this, there are some world-class engineers out there who have never really embraced production. They're great, and their brains are so big, and they're so good at modeling complex things that they've gotten a long way without ever really embracing the messiness, the dirtiness, the grittiness of production. And I just think that those days are kind of coming to an end. You have to learn the toolkit, you have to value the tool set, you have to invest in this stuff because we don't know what we don't know, and what we don't know is most of it.
You mentioned Observability 2.0, and I did want to get into that. What exactly is Observability 2.0, and does it have anything to do with AI?
So I kind of hate the term Observability 2.0, even though I'm responsible for coming up with it. And some feathers have definitely gotten ruffled at calling, let's say, the previous mental model 1.0. So I'm kind of trying to move away from that and towards just being like, all right, there's a multiple pillars model, right? Where every request that enters your system, you store in a metrics backend, you store in logs, maybe structured logs, unstructured logs, you store it in a tracing backend, you store it in a profiling backend, you store it in exceptions and errors, most vendors are storing their stuff in 10 to 20 tools, which are not connected to each other. Or there might be some tiny little bridges that have been like, okay, this metric over here connects to that dimension in that log line. So instead of calling it 1.0, I'll just call that the multiple pillars world, right? And if you look at all of the observability startups that have been founded since 2021, the ones that still survive, all of them have been built around a very different mental model, which I've been calling 2.0. You could also call it consolidated storage or unified storage. And it's built around this idea that instead of making those decisions at right time, you instrument your code around events. And you make these arbitrarily wide, structured data blobs with lots of context. And almost all of these tools are built on top of columnar databases. So you don't have to predefine indexes. You capture the data in this format, these really wide, structured log events, from which you can derive metrics and summary statistics. You can derive logs. You can visualize them over time as a trace. And because there's the one place that you store it, it's more cost effective, but also there's no dead ends. Here's your spike in your metrics saying, those are the log lines that generated it. Here's the log that you care about. Here is it visualized as a trace. And the thing is that the multiple pillars world, as our systems skyrocket in complexity, the wheels are coming off. Because the context that connects your metric store with your logs and your doesn't exist. So the only thing that connects them is what's in the engineer's head, which means that traditionally the consequence of this is that the debugger of last resort is always the engineer who's been there the longest. Right? Like, I think we're all familiar with this phenomenon. I always just assumed, well, that's just an artifact of computers. But it turns out it's not. It's when all that connective tissue sits in someone's head instead of in the tool. But when you take that connective tissue and you put it in a tool, everyone has equal access to it, everyone sees the same depiction of reality, then your best debuggers are the people who are the most curious. The people who always look up on their code after they ship it. The people who are used to doing observability-driven development. The people who know what good looks like and feels like, and because they're always in it. So to your question about how this interacts with the surge of AI stuff, the skyrocketing complexity, the fact that any attempt to cleanly delineate or separate out generative AI observability from software observability is just kind of doomed. And in reality, data is made valuable by context. The more context you can pack into something, the more valuable every bit of that data is. And so I think that generative AI and the rise of AI in general is going to accelerate people's paths to this. Because honestly, why wouldn't someone use a 2.0 or consolidated storage if it's cheaper, it's faster, it's easier? Well, because the tools are less mature. We've got 30 years invested into the multiple pillars world. And more importantly, anytime you're asking people to switch their cognitive model, there's friction, right? There's cost. It takes a while. You've got people who have spent their whole lives educating engineering teams on how to construct good metrics and what to put in a log versus a trace. The payoff has got to be there for people to make that switch.
Speaking of changing mental models, we're going from, I'm quoting another recent blog post now, you called generative AI a weird new kind of storage engine and agentic AI a weird new kind of computer. So,
That was my coworker,
oh, okay.
Philip. He published this blog post about why LLMs are a weird new kind of computer, and I love it. It's a little bit brain breaking, right? When you're like, computers have applications that run
Right,
on them. So do these. They are programmable. So do these. But I
right.
think it's helpful because the first generation of AI stuff, it didn't reason. And I think it was easy for a lot of people to kind of brush off and go, well, they're never going to be able to like think creatively or blah, 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 blah. Not so clear that that's the case. A
Right.
lot of people compared the first version of generative AI to really fancy autocomplete.
Mm-hmm.
And it was, because it was just pattern matching and filling in the blanks based on what it had seen. It wasn't doing any reasoning. But newer versions are doing reasoning. It's a kind of reasoning that's very different from the sort of binary computation. And again, I think these are the early days. We don't really know exactly how to use this, but it's going to be really interesting. I do think one of the things that we're going to see is a real explosion in software that is essentially disposable, that you just take it for granted. Nobody's going to need to understand it. Nobody does understand it. You're going to write it to a specification or to a description or to something, or maybe you'll generate 100 versions of it, right, and see which one fits the criteria the best. I think the closest analog for me is when the camera was invented. Because most of what painters used to do is paint little miniatures of people so that people could
Right.
poke around their loved ones' faces. And then the camera came out, and all of a sudden it was like, oh my God. And this kind of led to the rise of modern art. It's just this crisis in the art world about what are our skills good for now. I don't think software engineers should be panicking. There's also the software that runs the world. And from a risk management perspective, I don't see a straight line to us not needing to understand the code we write for at least 5 or 6 years. Like, it's hard to see longer than that, right? But like
Right.
banks, delivery companies, being able
Yeah.
to reliably give an answer to what happened is arguably the most important quality of software.
So, at least for the time being, is there anything that agentic AI changes about observability or vice versa?
This is something I'm keeping a very close eye on.
Right.
In fact, my coworker Fred Hebert and I are writing a talk for SRECon uh,
Oh,
next
cool.
week, which is
I will be
basically
there.
oh, sweet. Which is just basically like SREs are traditionally like gatekeepers. They're the ones who say no. They stand to thwart history, yelling stop. And I really feel like in parts of the industry, hype is huge, and then parts of the industry saying no is big. And I feel like in order for us to be trusted gatekeepers, you know how they say that good lawyers never tell you no? They tell you how to get to yes.
Yeah. Right, right, right.
Feel like that needs to be our role too. We can't just sit here and throw pot shots and critiques at this stuff. We should do that too. But we also need to recognize the opportunity, recognize most of the engineers in the world don't actually have access to a world-class SRE. If we could give them an agentic sort of solution that's only 30% as good as a great SRE, that's a massive value add. And if we in the SRE community don't acknowledge that, then we're going to get left out. I don't want to see happen to SRE what happened to QA 15 years ago. You know what I mean? They became obsolete, or their role became vastly reduced because people started to realize how much better software became when software engineers were the ones writing the tests, because it shortened those feedback loops, which compressed them, and it made software better. We've recently discovered the same thing about being on call for your code. We've realized it makes software better when engineers own their code instead of lobbing it over the wall for ops teams. Now, Operating software is the hardest part of software, and I think that there can and should be a really rich, meaty role for SRE and people who love operations, but that means we need to participate in this conversation about agents, not just opt out, not just criticize. I feel it very strongly that you don't help solve collective action problems by opting out of them, and that is my worry that SREs will do.
So, what is the SRE role, especially as we head toward that idea of disposable software? How do SREs stay a part of that conversation?
The world of software continues to expand. We're still going to care about quality. We're still going to care about operability. We're still going to care about our users. And that's a real thing, though. If your competitive differentiation does not involve a good user experience, then you probably don't have a need for a lot of SRE stuff. If it does, then you probably do. It's going to look different, and it might look something like what's happened to infrastructure engineers. It used to be every single tech company used to have infrastructure engineers. I was like one of the last wave of generations of people who page in the middle of the night, call a cab, and take a taxi downtown to flip the power switch on the MySQL primary. Now infrastructure engineers still exist, but all of my ops engineers work for Amazon. So it could be more of a specialist service platform type thing. And then there are just different types. If reliability is part of your value prop for a delivery company or something, then I think you're gonna need SRE help.
Right. But with agentic AI on the way and people being sold the concept of self-orchestrating systems,
Yeah.
is there a way that SREs should add some skills relevant to that to their arsenal? Is there anything like application developers have had to embrace prompt engineering, for example?
I think that the best thing that SREs can do is it's almost a psychological thing. Learn to embrace them. Don't see this as a threat. If you see it as a threat, you're kind of dooming yourself. There are analogies here. A couple years ago, so many designers were just refusing to use these tools because they were so afraid of it taking their work or taking over for them. That is the quickest way to guarantee that you will not have any work as a designer, is to refuse to learn to use these tools to do better work. Don't do that. The way to succeed in this industry has always been to embrace change and to embrace the idea that technology can help make you better at your job. And yeah, sometimes this means that fewer of you can do more stuff. But my favorite thing about that article that Philip wrote about LLMs being a weird new computer, he said something about a lot of dumbasses in company leadership see AI and salivate at the idea of headcount reduction so that AI can do the work. If you're a company leader who sees a wave as large as the introduction of the computer, and your thought is use less resources to do the same work, you're an uncreative hack and it's you who deserves to be fired. I was just like, yes, this is the same as automation. Like, I have seen some ops people who were like, we can't automate this stuff. This is my job. And where are those ops guys now? They were the ones who got left behind. There are political aspects to this. There are organizational aspects to this. I am not trying to say that everything's going to be hunky-dory and we should be... But I am saying that on an individual level, if you want to be relevant in 10 years, you need to embrace some of this stuff, you know? And one of the places that I feel like SREs are uniquely equipped to help, where I think our natural skepticism and dubiousness and always looking, it's not if something's going to fail, it's how it's going to fail, when it's going to fail, is looking at when we're bringing these tools into our workplaces. There's been a lot of cognitive research around what happens when you stop doing the work and you start supervising the work. Your skills decay. You become less powerful. You become less good at your job. Now, this is not like a law of gravity. These are workflows that were designed. We can design different workflows. We can make sure that we are adopting workflows that make us better at our jobs, ones that bring us along for the ride. When looking at the first wave of agentic SRE agents, and it's so tricky because the promises that founders want to make to VCs to make lots of money are usually like the exact opposite of the promises that you actually want to accomplish. They want to make it magic, but if they're out there selling, hey, you don't have to understand this, we're just going to go figure it out, tell you what the answer is, fix it for you, you should run away screaming. And if they're telling you, we're going to do some of this very tedious toil, we're going to scrape up the logs, look for common patterns, come and be like, here's our hypothesis, what do you think? And have it be a conversation as you're getting better together, you're learning. I think that's fantastic. I think that's amazing. Like I said, most engineers don't have access to world-class SREs. What if you had an agent so you're writing and shipping a microservice, and you're a decent software engineer, but you're not an expert. And so we can take a look and go, oh, health checks. Or when this is down, what about graceful degradation and exponential backoffs? And, just sort of like a checklist of things that to SREs are like, oh, this is obvious. But it's not. It's not actually obvious. That operational wisdom can get baked into a tool that can help make us better at our jobs. And if SREs see that and are like, I'm getting automated out of a job, we need to check that impulse in ourselves. What can you do with that extra time and energy when you're not having to coach someone through this for the thousandth time?
This technology is developing very, very fast,
Yeah.
but there is also going to be, as you mentioned, a time period where it's developing. But where do you think the space with agentic AI will be in a year? How far along do you think we'll be?
Agentic AI to do what? I think there's such a massive range of things that
Replace SREs, let's say.
replace SREs. I don't think anyone's going to be able to credibly make the claim that they can do that. I do
Okay.
think within a year. I do think that they could credibly make the claim that if you don't have any SREs, we could make you better than you were without one.
Okay.
Especially if they're smart about designing workflows that, like I said, bring your engineers along with you. Because if all you're doing is replacing a bunch of toil with a magic black box that tells you when it's done, then the next time the site goes down, you're in a worse place than you were before you offloaded that toil, because
Right.
now you don't even know where to start. This is so reminiscent of the conversations that we've been having about observability. There's a real market. One of the things that blew my mind when I became a CTO was realizing that most CTOs, VPs out there actually trust vendors more than they trust their own employees, because employees come and go, vendor relationships last forever. And I was just like, oh, what? But it makes them susceptible to the message that, hey, yeah, it's a lot of money, but you pay us $10 million a year, we will fix your observability problems for you. When in reality, you can't actually buy your way to good observability. A great tool can help, but I'm working on a piece right now about, is your observability a cost or an investment? Because the difference is cost just costs, investments pay off, right? They pay off, they pay for themselves and then some. But that only happens if it aligns with your business differentiators and you pick up that ball and you carry it. If you're actually using the observability to bring down deploy times, improve mean time to recovery, make it easier for people to collaborate. And that takes extra work.
There's always more work to do, of
There's always
course.
more work to do.
So on that note, thank you again for joining us. It's always great to talk to you.
Yeah.
And I'll see you next week.
I'll see you next week. Thanks, Beth.
This has been IT Ops Query Season 3, Observability in the Age of AI. If you have any feedback on this episode or want to share questions, comments, or stories we should consider covering, please reach out to me at beth.pariseau, that's Pariseau, at informatechtarget.com. Please consider rating, reviewing, and subscribing to this podcast on your platform of choice, and tune in next week for our continued conversations with industry experts about how observability is shaping AI and how AI is shaping observability.